With the whole AUR malware situation going on and the AUR moderation team working on some sort of mitigations to make sure this doesn't happen again and again and again, such as delays until packages can get published, manual review of commits, some automated scanners for package builds and things of that nature. But until that happens, and even after that happens, there's likely still going to be some level of malware on the AUR. And even if it's not malware, sometimes packages just don't build correctly. Sometimes things might do weird things in the background. Like, for example, there was a time, not an AUR package, but still very important, there was a time where if you moved your Steam directory, Steam would delete your entire home directory. That was a problem. That was a big problem. So even if it's not intentionally malicious, you still should be verifying that the package you're installing is doing what it should be doing. With that being said, how does one keep safe on the AUR, both pre and post install of a package, and then when you go and update it into the future? Before even considering looking at the package build, the very first thing you should do is make sure the basic things actually make sense. With basically anyone being able to upload a package to the AUR, there is a serious possibility for typo squatting. This is where someone exploits the fact that sometimes you don't write words correctly. Sometimes you slightly misspell it, and maybe you land on their package. Now, thankfully, the AUR moderators tend to clean these up pretty quickly because it's pretty obvious when there's 3 different versions of a package, all with them being just slightly differently spelled. There's usually not a reason for that. This is quite common, though, with crypto packages, because if they get a crypto wallet, well, they get everything. If they get your keys, you're done. So, Exodus here, this is a real crypto wallet. I have seen packages like Xedis, where the O is replaced with an I, or Xodis, where the U is replaced with an I. And yeah, if you're looking at it closely, you're not going to see that. But when you're installing a package, make sure the package you're installing is the package you intend to install. But how do I know it's the right package? Well, firstly, does the name actually make sense? In the case of Exodus, maybe you would see an Exodus wallet, because maybe there was already a package on the AUR by the name of Exodus. This is entirely normal. This is quite common, especially for commonly used words. That could be legit, okay? Totally fair. But if it's just misspelt for the sake of being misspelt, probably not then. Also, if there is official documentation from the project and they list out the AUR installation method, they will tell you the package to install. This right here is for Brave Origin. They officially maintain the package. They have documentation on using the AUR. They list out the specific package name to install. If it is not this name, it is very likely not legit. But in the case of Brave, there are different variations of this package as well. So this is the regular version, but you might also see the beta version. This package here, with beta in the name, this is also legit. Same with the nightly version as well. So just because there is a variation doesn't mean that it is fake. But just make sure that things line up in a way that makes sense. If things don't even do anything further. The package, just ignore it entirely. Better yet, go and report it to the AUR moderators, because something is clearly wrong there. If it is spelt wrong, that's probably malware. That's probably something malicious. With that being verified, let's consider some other information. Let's stay on the webpage. We can see some of this stuff in the package build, but it's laid out nicely on the webpage anyway, so we might as well use it. Next up, look at the sources. This is what is being pulled in by the package. This is going to include your binaries, your source code, any patches. For example, LibreWolf, we have this patch here, we have an image, we have some sources, we have a desktop file, whereas LF, it's just got LF here. Look at where that points. In this case, this is pointing to the LF Git. Is that the place where LF source code comes from? Yes. Let's go to LibreWolf. This is pulling in stuff from a Codeberg. Is this the LibreWolf Codeberg? Yes. This is pulling in a patch. Is this a patch that makes sense? Now, this is something which might be difficult for some people to do. You will need to understand some level of code. Is what it is doing here anything weird, anything strange, or is this a normal kind of patch you might make? Well, if you're not sure about it, you can always just go and ask someone. Like, that's the easiest thing to do. Or, if you want to, there are LLMs out there, but my best suggestion is at a very, very minimum, learn some basics of code. Then we have this LibreWolf desktop file. Is this file a normal, reasonable file? By all accounts, it's a bit of a long one because it's LibreWolf, has a lot of translations in it, but to me, it seems like a totally normal file. Some packages are going to be a lot more complicated than others. LF is a terminal application. Typically, these tend to be quite a bit simpler. If we consider the binary version of LibreWolf, where is that binary actually being downloaded from? In this case, it is coming from that same Codeberg. This is the place where binaries are distributed from. If you're downloading a proprietary application like a Discord, that's probably going to come directly from the Discord website. If it's coming from some other random website, why is it doing that? What is that website? What is it actually downloading? Is there a reason for it to do that? Or is it trying to hide something? There is no one singular answer for what you are looking for here. This is going to entirely depend on the application you're looking at, so my recommendation is learn where the application comes from. Is it open source? Is it proprietary? Does it use GitHub, GitLab, Codeberg, a random self-hosted Git server? Is the source code coming from a place that actually makes sense for the project, or is it just pulling some random thing that you've never heard of? Because if it's pulling some random thing you've never heard of, that's probably an issue. Next up, look at the votes, popularity, and the comments. This indicates that there is some sort of activity on the package. Now, it doesn't mean the package hasn't been compromised. It doesn't mean that none of this has been faked. You can absolutely fake all of this with AI or just a little bit of work and a little bit of time. That's all very easy to do. However, it's an indicator. It is a signal. None of these signals by themselves should be treated as a guarantee that this package is safe. But if you see a lot of activity on a package over a very long time, generally that is an indicator, that is a point on a graph, and that graph has a trend, and that trend goes in a direction. But there are completely legitimate packages like lf-git where things have been good for a very long time, and the latest comment is from 5 years ago. This doesn't mean the package is bad. This doesn't mean that something malicious is going on. So it cannot be used in a vacuum to say, this is good, this is bad. But if people are saying, this package is bad, don't install it, that's usually a pretty good indicator that something is wrong. But also, don't be afraid to look off-site. If you're not really sure about the package, go look on YouTube. There are going to be videos discussing it very likely. Go look on Reddit. Go look on forums. I know some people don't like it, but go and ask an LLM. Yes, I would say use that as like a final resource if you're just not really sure, but go and ask people. Go and ask on the Arch forums. If nobody's asked the question, go and ask it on Reddit and see if anyone has an answer for you. There are these sort of dedicated beginner places out there that you can ask questions like this to see if somebody has an answer. If you don't know, other people are out there who are willing to do this check for you. Next up, look at the submission date. The AUR is very, very active in getting things published. So if something has been around for 10 years, it's very unlikely the package is going to be 5 days old. LF's case, this is from 2016. Over here with LibreWolf, this is from 2019. I don't have the Exodus page opened anymore, but you're going to see this quite often where things that you know about are probably going to be packaged. Frankly, things you don't know about are probably going to be packaged as well. If you see a, I don't know, Firefox package that's a week old, that's 3 days old, that's fake. I don't need to look at anything else. That's fake. The AUR is so big, that is such a big application, there is no way the package would be new. But it is not a guarantee. Sometimes projects are recently revived for modern systems, and then they get packaged on the AUR, so it's a very recent package, even though the project is 37 years old. Again, these are signals. Also, go and do a search on both the package submitter and the package maintainer. In the case of LibreWolf, it is the same person, so let's go and copy that, and then change this to maintainer. We can also change to submitter, so let's go maintainer for now, and then search that, and let's see what we find. We have LibreWolf, another version of LibreWolf, OpenSnitch eBPF module-git. Now, sometimes a maintainer will only maintain a singular package. That is totally normal. However, if they maintain a bunch of packages that you know about and that you know already are safe, that's generally a good indicator that this package is also safe, that this package is also well maintained. Don't trust it too much because someone might have a compromised account, but usually when they're not compromised, evidence of prior work is an indication of future work. With all of that out of the way, now I think it is time to look at the package build. Now, there are a number of ways you can do this. One is on the webpage, go to View Package Build, and here it is. There's also a log of all of the prior commits here, so you can see the prior versions. Check out the prior versions as well. That is also very important to know what has changed between each of these. Also, there is a diff between the previous and the latest change. So if you want to see that as well, that can also be done. If you're checking from your AUR helper, Peru is going to show you the package builds by default, as long as you don't just skip past it and don't bother reading it. In the case of Yay, it doesn't, but you can do Yay-G, and that will get you the package build. If you're doing a manual installation, well, I hope you're not watching this video if you're doing manual installations, because you're doing manual installations, but when you're downloading the Git repo, you will get the package build, and you have the Git history, so you can access the entire Git history. First things first, what is a package build? Well, it's a bash script. That's all it is. It is a structured bash script. It is a bash script with very specific variables being defined, and very specific functions being defined. That is all. It's not a weird format you've never seen before. It's just bash. These variables here, this is what was populating the page over here. So we see something like license equals MIT. That is how it gets this information. We have the depends list that lists out the dependencies. We have the make depends. We have the architectures. We have the URL, the sources, all of this stuff, the provides and conflicts. All of this is just populating the page, and then these functions down here are what are used to actually make the package, to actually install it on your system. Technically, they're only part of the equation because there's also the Arch build system, but these are the parts that you actually control. Whilst there are a set of core main functions, it is a bash script, so any additional functions can also be defined, and this is normal. You will often see functions being defined for various things, especially with more complicated packages, but more importantly, it is bash. You can run basically any command that you could possibly want inside of this. There are a few exceptions, but they're not really relevant to today, and they're not really relevant to the whole malware discussion anyway. Basically, anything can be run here, so anything that would be dangerous to run in your terminal would also be dangerous in a package build. I know some people might not like to hear this, but you are gonna have to learn how to build the software that you're trying to install. So there are a set of core functions in a package build you're going to see over and over and over again, and they all have a specific function. we have the package function. This is used to install files into the directory that will become the root directory of the built package. Let's say, for example, in the lf package, we have this. You are going to see install commands over and over and over again. If you don't know how the install command works, if you don't know what these specific options mean, there is documentation on how install functions. But if you don't want to check that, hey, it's fine. You can compare with packages that are known to be safe with the package you are looking at. This is a normal structure you will see. Now, lf is a very simple package, so for something like LibreWolf, for instance, this is the binary version, but even so, LibreWolf is going to be a bit more complicated overall, just because it's a far more complicated application. You'll often see files being copied, directories being changed, symlinks being made, removing specific things that are being used during the package installation process, chmodding files, and all of this stuff is normal. Now, make sure it is doing that on files related to the software, but the commands themselves would not be out of place. One that you'll rarely see is verify. This is used to verify the sources being used. Oftentimes, it's just skipped, like checking the SHA sums, also often being skipped. We have the prepare function. This is used to get the sources ready to build. So if there are any patches being listed by the package, this is where those patches are being applied. What are those patches? Should they be applied? Do they make sense for this package, or are they trying to inject something malicious into the code? Build is used to compile the software. This is going to be entirely dependent on what language the project is built in. In the case of lf, this is using Go, so it's using the Go toolchain. If you're using something like C, you're probably going to see some make commands being run. If it's Rust, it's Cargo. If it's Python, well, you don't necessarily build Python code, so this is going to be a much simpler function. Package.ver is another one you don't always see. This is used to generate the version number used by the package. Oftentimes, a package version number is gonna be something very easy, but sometimes it needs to be a bit complicated, so there is a function there that can be used instead. Also, we have check, often skipped, used to run the application's test suite. A lot of the time it's skipped because it just takes a lot of time to run, and most people don't actually care. But, as I said, this is a bash script. These are functions being run in bash and can run anything that bash can run. This is what each of the functions should be doing. However, where's the one? However, that doesn't necessarily mean they are. LibreWolf here is doing what it should be doing. lf here is doing what it should be doing. lf is quite a bit easier to read. But there's no reason why in build it couldn't just nuke your entire home directory or start installing random applications, start running random commands. If something doesn't fit in that specific function, it's not necessarily malicious, but it's something that should be reported. Now, it very well could be malicious, in which case, definitely don't install it. But it might just be, someone new to packaging in the AUR and not entirely sure on what each function should be doing. One thing I skipped over earlier, which you also should be checking, is the dependencies. What does this rely on to actually run? Now, lf is very simple. It's glibc, it's git, it's go. Basic, nothing crazy. Something like a LibreWolf is going to be a lot more. But I mentioned this one specifically because whilst the dependency itself might be entirely valid, it might be entirely safe. For example, it might have a dependency of npm. Why does it have a dependency of npm? Why would, say, a Go application need npm? Why would a C application need npm? Why would a Python application need npm? Now, there might be a valid reason for it. There very well might be. But if a random dependency is added, what is that doing there? And does that align with the build instructions from the project? What do the dependencies say about what the package is trying to do, because most projects out there have a set of dependencies that are needed by that project. They're listed on their Git, their whatever source forge they happen to be using. The package names might not align because maybe the instructions are for Ubuntu or for Fedora, but when you find the packages that do align, do the packages listed by the AUR align with the project? Because again, if not, there's an extra dependency there, and it might be fine, might just be a mistake. But it also might be like the NPM case recently, where that was being added into a bunch of packages and being used to install an info stealer. Now, usually, people are not so dumb to hide their issues in plain sight. But we also have the pre-install, post-install, pre-upgrade, post-upgrade, pre-remove, and post-remove functions. These are functions run at their specified times. These are used to prepare the package if something is being done in that situation. Maybe post-remove, some files need to be cleaned up, maybe remove and config files, things of that nature. It's not often done, but sometimes it can be done. Why is that function there? Is there a reason for it to be there? Is it doing something that makes sense? Or is it trying to RF your home directory? Is it trying to install some malware on your system? Is it doing something relevant to the package? Or is it just there for the sake of being there? Whilst we haven't seen it today, there can be another file alongside the package build if defined to be used by the package build. That is the install file. This is a separate file from the package build that is used to execute commands after install, upgrade, or removal stage. This is basically a dedicated file for those pre and post hooks. If this is defined, if this is being used, make sure you apply the exact same checks to that file as well. That is also a script that can also run dangerous things. If it is there, it's usually going to be fine. But it can be a place to hide things. Whilst I've shown you a bunch of normal looking commands, if you see anything that appears to be obfuscated, it appears to be something where it's trying to hide something, like a random base 64 string. Why is that there? What is it doing? If you see something like this, which is a part of the recent malware situation, what are you doing here? Why is this here? There is basically no valid reason to try to obfuscate the command you're running inside a package build. 99.99% of the time, this is doing something malicious. But there is a slight possible chance it's not, and they're just trying to do something weird. If there is anything you're unsure about, ask. Ask with your preferred method, whether that be an LLM, a friend, a forum, all of the above. Ask. Ask someone else before you go and do something that might be dangerous, because whilst the AUR is mostly safe, there are these cases where things go wrong, there are these situations where things are bad, and these should be dealt with by the AUR team. However, sometimes they are missed, sometimes they have not yet been found, so you need to be vigilant. So, stay safe out there. I know it's hard, it's gonna require learning, it's gonna require learning how to build software and write software to some extent, or at least very basic surface level stuff, but it's required. Anyway, if you liked the video, go like the video, go subscribe as well, and if you really liked the video and you want to become one of these amazing people over here, also let me know your thoughts down below. Check out the Patreon Scribes Daily Bureau Pay linked in the description down below. That's going to be it for me, and hopefully I don't need to talk about the AUR once again, but we'll see how that goes. Maybe a bit of a delay.